Now about laying out a slider crank. In the notes field of the second slide, I've given you this link to a Wikipedia page. Hopefully it still works. And they have several animations on this page, a drag link and several others, and a slider crank. You can see this is really crude and simple, but it illustrates how a slider crank works. In the animation on the bottom, the fixed point and the slider are lined up in a line. So you can see that the slider just slides back and forth horizontally, lined up with that. In the animation on the top, the slider is not lined up with the crank, and so the stroke length will be it won't be 2 times the crank, it'll be some other number. But still you can see here's the crank going around, and as it does, it pulls that slider back and forth in a straight line. And notice those bars are not stretchy, they're not made of rubber, they're made of something that doesn't stretch. And so you can figure out how long they are and where they're going to move to. Alrighty. So let's look at this slider crank situation. As you saw in that animation, it converts rotary motion from the crank into linear motion from the slider. Let's look at an example that's in our book here. In this example, he has the pivot of the crank and the slider all lined up on a straight line. And he says that crank, AB, is 1 1/4 inches long. The connecting link, BC, is 3 1/4 inches long. And we're supposed to lay out the schematic and then find out how long is the stroke length. And this is not the homework problem, this is just an example out of the book. So we know that that crank doesn't stretch, and so the point on the end of that crank is going to land somewhere on a circle whose radius is 1 1/4, isn't it? So as that crank goes around, that pin on the end is going to trace a circular path, and it's going to be a radius of 1.5. Now to find the extreme right position, the stretched out position, what do we know? We know how long the crank is, and we know how long the connector is, and so when they're stretched out straight as far as they will go, what is the radius of that circle that they trace? What is the length of that stretched out thing? It is the connector, 3 1/4, plus the crank, 1 1/4, so that total stretched out length is 4.5 for this example. Your homework problem will have different numbers. So you can draw a big old circle with a radius of 4.5, and that slider is going to land on that circle somewhere. Then for the extreme left position, that connector is going to fold up over the top of the crank, isn't it? And I've tried to show that crudely here. So the connector is 3 1/4 inches long from B to C, and it folds up over the crank, which is 1 1/4, AB. And so from the center of the crank out to this end point where the slider is going to be connector 3 1/4 minus crank 1 1/4. It's going to be a radius of 2 inches from A out to C. And so I have drawn a part of a circle that size. That is going to be the extreme left position of that slider. Now notice that in this case the pivot that the crank turns around and the slider are all lined up in a straight line. So the stroke is going to be 2.5 from the right to the left. That's twice as long as the crank. He told us that this crank is 1.25. The total stroke, you will find, will turn out to be 2.5, exactly twice as long. The situation you have in your drawing assignment is that they're not lined up in a straight line. They're more offset, or they're at different heights, like these guys are here. So here's the problem that we have. And he sneakily tells us, all right, well, here's the position when the crank happens to be lying at a 60-degree angle. Then the stroke happens to be that far out. That's just some sort of middle territory there. So, but that will let you lay out this schematic. And what you need is the crank and the link, the crank and the connector stretched out in a straight line as far as they will go to the right, and the crank and the connector folded up over each other, so that'll be as far as they go to the left. And that will show you the far right and left positions of the slider. That will let you dimension the stroke. And here are two different versions of what your answer might look like. Notice each person has used different line types. This one on the right I think is out of the solutions manual. The one on the left I think is somebody else did that. Yours will look similar to these. You don't have to make them identical, but basic idea, and that will allow you to dimension this stroke, which, as I recall, was around 2.185, if I remember right. So what you'll do is you'll draw a circle for the short crank there, and then you'll draw a big circle whose radius is the crank plus the connector stretched out straight. That big circle will be centered on the center of the crank, and its length will be crank plus connector. Then you'll draw another circle centered on the crank, and its radius will be connector minus crank. And there's that circle. And where that circle intersects the height of the slider, you can just draw the slider there, where the long stretched out to the right circle intersects the height of the slider, you can position the slider there. And so you'll have the far right and the far left positions, and you can dimension the stroke.